Okay, in this video we're going to introduce you to what is known as the unit circle. I'm going to introduce it to you in a way that applies our special case triangle properties to help you create the unit circle, so that hopefully it will help us as we memorize it to be able to essentially memorize a fourth of the circle and then reflect and rotate kind of around the circle to fill in the rest of it, so that we're not memorizing the whole thing at once, but understanding where it comes from to complete or fill in the circle. You'll notice in the guided notes packet you have this circle here on the front that is not labeled in any way, so we're going to complete that. And then you have the second page that talks about just working with quadrant 1. So you'll notice that I've kind of screenshotted quadrant 1 so that we could build some patterns and then go back and fill in on our circle what quadrant 1 would look like. And then again, we will reflect it around into the various quadrants. You haven't dealt a lot with circles on coordinate graphs yet, particularly with like the unit circle and circular angles. So I'm going to introduce you just a little bit to that as we go, but I won't go in depth into any of those topics in particular. So first of all, let's define here up at the top. This says a circle of radius 1 is called a unit circle. So it's very important when we talk about this particular unit circle, I'm going to deal with a circle of radius 1 and only a circle of radius 1. So this radius here, if I was drawing it, you'll notice the center on the circle, and I'll try to use some various colors down here, but the center right here is sitting at 0, 0, which means then as I move out to the edges of my circle or the circle itself, I am going to move 1 unit. So this point right here, these are probably the easiest points to find on the unit circle. If you look here to the right, this length of my radius is 1 unit. So I actually know that on my graph, if this is the x-axis and this is the y-axis up here, that this red point that I drew would be at the point 1, 0, because we've moved 1 unit to the right and no units up or down. That would be the point 1, 0. I could do that with the other points as I move around and kind of rotate. Up here at the top, this point on my circle that I just drew the green dot, I'm not sure green's a great color on this, but it would be at 0, 1. And to the left here on my circle, this would be at the point -1, 0. Again, because the radius is 1, all of these points are 1 unit away from the center. This one down here, we could say it's at the point 0, -1. So our goal really in building the unit circle is to identify what all of these points represent. And as it's stated up here, this is a 16-point unit circle in the sense that this would represent 1 point. There would be another point here and here and here. And we want to write each of these in exact form, and we'll relate them to our trigonometry as we go as well. So that's just an idea of what we're looking at with the unit circle. Again, radius of length 1. Another thing just really quick as we kind of move into particularly quadrant 1 is just recognize that when we talk about building a circle with using degree measures and other things like that, this is my initial side, and as I take this initial side, if I were to call this say 0 degrees, as I rotate up and I rotate like this direction and I take that side in a rotational way, counterclockwise, I create an angle. And we're going to talk about what those different angles would be on the unit circle. If I were to rotate this side here up directly here, we can see that that would be a nice 90-degree angle, right? If we take this side and we rotate it all the way here so that it makes a straight line, now we've got a degree measure of 180 degrees. If we go all the way here, and we're looking at this guy, we're at 270 degrees, and if we go all the way around the circle, we would be at 360 degrees. We are not going to go larger than 360 degrees for now, so we will just worry about that as we go. Sorry, I'm going to change this color, maybe, I forgot how. Oh, there we go, to like a blue so that it looks a little different than that. Okay, so what I'm going to do, I'm going to label this 0 degrees just so I remember that that's 0 degrees. This guy up here, if we were rotating, the angles would be 90 degrees. Again, this one over here is 180 degrees, and this one would be 270 degrees. So those are probably the simplest parts to look at on the unit circle. Now let's dive in a little bit deeper into these kind of three pieces that we see in each of the quadrants. And again, I'm going to start on this next page and just talk about quadrant 1 to start with. So here I have quadrant 1. I'm going to fill in some of the pieces that we just looked at, where this first point, because the radius is length 1, would be at the point 1, 0. This one up here at the top would be the point 0, 1. Okay. From there, I'm actually going to construct some special case triangles as we build our unit circle. So I am going to, in particularly, take this point and we're going to deal with this one first. Now, to do this, what I'm going to do is I'm going to actually drop this like altitude looking line down to create a 90-degree angle here. And the reason I'm going to do that is I want to create a nice little right triangle so that I can use my trigonometry to help me figure out where this point is on the graph. Now notice this point has a radius of 1, or this triangle, which is actually the hypotenuse of the triangle. So we're looking at a right triangle where the hypotenuse is 1. And this first rotational angle measure we're going to call 30 degrees. Okay, so this is one of our special case triangles. It's a 30, 60, 90. And I'm going to come over here and I'm going to draw it just so that we can kind of see it. Remember in the 30, 60, 90, when we had a triangle here, we had a 90-degree angle, and our 30-degree angle was always opposite of our short leg. And we referenced everything through the short leg. If we knew the short leg, we could figure out the hypotenuse, because the hypotenuse was just double, or 2 times the short leg. If we knew the short leg, then we knew that the long leg was just the short leg times by square root of 3. So using the same idea, if I come back to this triangle and I'm looking at this, and I'm going to use the laser tool just so that it erases it in a minute, but if I'm looking at this guy right here as a right triangle, and this is 1, and this is a 30-degree angle, then my short side is this side over here. So if the hypotenuse is 1, the short side is half of that. So the short side here would actually be 1/2, because my hypotenuse is length 1. And then again, if I know the short side, then I write it as 1/2 times the square root of 3. We usually don't leave it in that form. We'll actually write the square root of 3 over 2, which is the same thing. But that essentially would be the side length down here. So I've got this hypotenuse of 1, the short leg of 1/2, and my long leg, which is the square root of 3 over 2. So now if I want to write the point right here, I just need to know what my x and y is. And notice the x value is just the distance moved in the horizontal direction, and the y value in the vertical direction. So this right here would be square root of 3 over 2, because I moved that far to the right, and then I moved 1/2 units up. So that point right there that I'm going to fill in is the square root of 3 over 2, comma 1/2. Okay. And again, that's relating particularly to that 30-degree angle, and that's how we come up with that point. Then we can do the same thing and use the same idea to continue through this. So the next point on our circle is halfway between 0 degrees and 90 degrees. So this right here is going to be representative of a 45-degree angle. And I'm going to do the same thing in building the triangle. So let's just remember the properties of a 45, 45, 90 triangle. So remember 45, 45 means that it's half of a square. So if this is 45 degrees, if I know one of the legs, then the other leg is the same, and the hypotenuse is just x times the square root of 2, or the leg times the square root of 2. So again, let me take this laser tool, and if I drop this altitude right here, this is essentially going to create a nice right triangle with a 45-degree angle, and we can do kind of the same thing here. Remember, the hypotenuse is 1 because that represents the radius of the unit circle, which is always 1. So if I know that that is 1, then I know that to find the legs, I need to divide out the square root of 2. And we don't like to leave radicals in the bottom, so we would just rationalize that by multiplying by the square root of 2, which in this case would equal the square root of 2 over 2. So if I come over here and write this, I have the square root of 2 over 2 as that leg, and remember the legs are the same. So this one actually moves the same number of units in the horizontal direction as it does the vertical. So we would write this as the square root of 2 over 2. Square root of 2 over 2. I feel like that's the easiest one to memorize because they're the same. Works pretty good. And then as you can imagine, if we're still using special case triangles, this next one is actually a 60-degree angle. So if we're looking up here, this is a 60-degree angle. And again, if I had to drop that altitude, you'll notice it'll create a 30, 60, 90. So here's an altitude. I create a right triangle. This is a lot like the other one. This is my 60-degree angle, which means here's my 30-degree angle. So again, if the hypotenuse is 1, this is just reflective of the other one we did. Here's my short leg, which is half of the hypotenuse. And then the long leg is just the short leg times the square root of 3. So again, this one is going to be 1/2 in the horizontal direction, square root of 3 over 2 in the vertical direction. So it's just reverse of our 30-degree angle, where we have 1/2 here, root 3 over 2 here. Okay. Once we have those points, we can reflect them into the other coordinates. So on our unit circle, coming back to kind of this main page, I'm going to fill in these points that we just talked about. So this point over here was root 3 over 2, comma 1/2. This middle one at the 45 degree was square root of 2 over 2, comma square root of 2 over 2. And this 60 degree line was at 1/2, comma square root of 3 over 2. Again, once we have those, you're going to notice that the other quadrants are going to just relate to that. So notice this one is the same height as that one, right? So it goes up 1/2, but this time it goes to the left, square root of 3 over 2. So as I reflect these points around, this one is negative square root of 3 over 2, but it's still at a positive 1/2. We're still above the x-axis in positive y values. If I reflect this middle one over to here, again, we're just going in a negative direction for the x value. The y value is staying the same. And up here, we've got negative 1/2 and square root of 3 over 2 as we once again reflect this point over into the second quadrant. And we're going to do the same thing all the way around. So now if I take this point right here and it becomes this point right here, notice it's still 1/2 distance in the y direction, but it's negative. And we're still on the negative side for the x value, so now both values of our point become negative when we are in the third quadrant. So we have negative root 2 over 2 and negative root 2 over 2 as our middle point there. And here we're reflecting down, we have negative 1/2 and negative root 3 over 2. Okay, again, I'm just going to go all the way around. Once we get back onto this side, we're on the positive side for our x's. So our x values stay the same, and we have a negative value in the y coordinate. So again, negative root 2 over 2 and positive root 2 over 2. Oh, I just wrote that one wrong. Sorry. Negative for the y coordinate, not the x. Okay, and then down here to this last one. Again, I'm going to have positive 1/2, but it's going to go negative root 3 over 2. Awesome. I'm going to fill in the rest of the angle measures now that we kind of have figured out what those angle measures would be. And instead of writing them all at the center so that I have like these crazy things going on at the middle, I'm going to just write them here on the line. So like this line right here represents that 30-degree rotation. This is the 45-degree rotation. This is my 60-degree rotation. And then if we want to fill in the other ones, maybe just look at some patterns we notice. So notice we jump 30 degrees every time there's a big slot, and then 15, 15, 30. So I can tell I'm going to jump 30, 15, 15, 30. So if I take 90 degrees and I add 30, I'm going to be at 120 degrees. And then if I add 15, that's 135 degrees. Plus 15 is 150 degrees. Then you'll notice if you add 30, you end up at the 180. We add 30 again, we end up at 210 degrees. Add 15 is 225 degrees. Add 15 is 240 degrees. And you'll notice when we add 30, we end up at 270 degrees. We add 30 again, we're at 300 degrees. Add 15, 315 degrees. And again, 330 degrees. Now again, I could give you a copy of this and we could just memorize it, but if we understand patterns and we look for those connections, then we can construct this by memory. And some of the things you'll just identify it, look at it, see if you can kind of build your own connections. One thing that I always think of when I'm trying to do this, just based off of memory, is I noticed that all the 45 sections that are related to that root 2 over 2, they all like end in 5s. So anytime I see one of these values that we're looking for, if I see that it ends in a 5, I know that it's the middle piece to each of the quadrants. So just little things like that you're trying to make connections so that you can memorize that. Okay, we are almost there. So we've got these built, we've got our points on there, we know what those represent. Let's actually connect this to then trigonometry. In the future and next year, you'll use this to construct your trigonometric function equations. So that's going to take us to the second part. This says, let's look at a point on the circle with radius 1. So again, it's the unit circle in terms of sine and cosine. So given that r is equal to 1 unit, so it's been drawn here on the graph, r is equal to 1 unit, x, y could represent any point on the graph. You'll notice that we put theta in here, so this is not just about one angle. It'll apply to any angle at any time on the unit circle. It could be one that was up here, right, if that was theta. So we just want to find something that's true all the time for every angle, so we're using theta. If this is the case, and if this little diagram is true, and this is the point x, y, then I would know that this must have moved x in the x direction and y units in the y direction. So if this is my triangle with theta as my reference angle and I want to identify the sine of theta, you'll notice that sine is just opposite over hypotenuse. Well, the opposite of theta is y and the hypotenuse is 1. So I'm going to write y over 1. Well, we know that anything divided by 1 is just y itself. So y is divided by 1 is y. And because it's the unit circle, the radius will always be 1. So a conclusion that we could make in describing how the sine values relate to the coordinate point is that the sine of any angle theta on our unit circle is the y value of the point. Okay. Now if we look at cosine in that same light, cosine of theta, using that same diagram, is adjacent over the hypotenuse, and the adjacent leg here is x over the hypotenuse, which is 1. So x over 1, same idea, anything divided by 1 is itself, and so that means that our cosine of any angle theta is just the x coordinate of the, I guess I should say coordinate there, x coordinate of our point. Okay. So for example, if I'm looking at this guy right here, and I'm going to zoom out just a little bit so that I kind of have both on here. If I'm asked to find the sine of 30 degrees, then I'm going to look up here at my 30-degree rotational arm, and you'll notice here's the point we came up with. Sine is going to be the y value of that point. So the sine of 30 degrees is 1, oh, I don't know why I wrote a negative, is 1/2. And you could check that on your calculator. If you plug in the sine of 30 degrees and push enter, you should end up with 0.5. Sorry, I needed a drink. Okay. Then if we look at sine of 45, so again, look up at your unit circle. 45 is this middle one. So sine is the y value. This would be equal to the square root of 2 over 2. And lastly, cosine of 60 degrees. Again, here's our 60-degree angle. Cosine is the x value. So the cosine of 60 degrees would be 1/2. Okay. So on your unit circle, one thing to remember, and I'm going to label this on here just so that we remember this. Again, the y values, so I'm going to point at the y value. These are all of your sine values. The x value is where you find your cosine values. Okay, so one of the things you'll practice with today is just that. If it says the sine of 120, you're going to try and figure out, well, what is the y value of the point at 120 degrees? And you can try and do this without looking at the unit circle on a few of them. It's really good practice and a good kind of brain exercise to kind of think through where it would be and how it would rotate and be positive or negative and then relate back to those points. The last thing that we're going to add is here at the bottom. This is going back to your unit circle, calculate and fill in the tangent values. So let's think about tangent using this diagram really quickly. Tangent of theta would be equal to the opposite leg over the adjacent leg. So in our diagram, again, opposite leg was y, adjacent leg here is x, so we would put y over x. So essentially, if I want to calculate the tangent, I'm going to have to actually go through and take my y value of my point and divide it by x. Now, thankfully, again, we can do it for quadrant 1, and then it will reflect around our circle. So I'm going to start by looking at the tangent of 30. So here's the tangent of 30 degrees. And again, it's going to be my y value, which is 1/2 in this case, divided by my x value, which is 1/3 over 2. 1/3, square root of 3, sorry. Remember, when you divide fractions, you just change it to multiplication and flip the other fraction, and then you simplify. So it looks like our 2's cancel. We get 1 over square root of 3. Some mathematical authors will leave it like that. Most will use mathematical etiquette and rationalize the denominator. We don't like radicals in the bottom. So we multiply by square root of 3, and we end up with square root of 3 over 3. So the tangent of 30, I'm going to write it right here just so it's clear, is the square root of 3 over 3. Okay. Now the tangent of 45 is probably the simplest one, because if you take the y value and divide it by the x value, your y value is the same as your x value. So anything divided by itself is equal to 1, which makes sense. If your legs are the same length and you do the opposite leg divided by the adjacent leg, it will be equal to 1. All right, last one here on this little piece. Tangent of 60 degrees is equal to, again, I'm going to write this here up at the top in green. I'm going to take my y value here, the square root of 3 over 2, and I'm going to divide it by the x value of 1/2. So remember, that's the same as taking that first piece and multiplying it by the reciprocal of the second. We simplify the 2 there, and we get square root of 3 over 1, or just the square root of 3. So now we've got our tangents there. So again, sine is the y value, cosine is that x value, and then we have our calculated tangents. Okay, so let's come back to the main circle, and we're just going to fill in the rest of these, and then we'll be done here. So let's add our tangents in here. I'm going to choose a new color just so you can tell that it's a new item. Let's go purple. Tangents, you can write them wherever you want. I think on your homework, I left like a line right here for you to write them on in each of the spots. So if you want to write them inside, you can, or if you want to write them hanging out on the outside, you can do that too. So the tangent of this guy would be the square root of 3 over 3. The tangent of 45 was 1, and the tangent of 60 degrees was the square root of 3. Okay, now again, I'm going to flip that and mirror it over into the next quadrant. Notice in the next quadrant you have your cosine value, which is negative, and your sine value, which is positive. So if you have a negative and a positive dividing, you're going to end up with negative tangents. So this one's negative root 3, this one's negative 1, and this is negative root 3 over 3. Those tangents become negative values. Okay, flipping down into quadrant 3, now we have this y and the x both are negative, the sine and the cosine. So when you divide a negative by a negative, they turn positive again. So we're going to have 1. Oh, I always do the 45 first. I don't know why. So that'll be square root of 3 over 3, 1 in the middle there, and then the square root of 3 here on the bottom. Good. And then I'm going to keep going around. So square root of 3, we're back to negative values because 1 is negative, 1 is positive. We get 1 and we get negative square root of 3 over 3. Okay, so there's our tangent values. Last thing I'm going to do is add the tangent values. Oh, I made purple and I didn't even use it. I'm going to do the tangent values of 0 degrees and 90 degrees and 180. If you look at like the tangent of 0 degrees, that would be 0 divided by 1, which is just 0. If we come up and we do the tangent of 90 degrees, the tangent would be 1, the y value, divided by 0, the x value, and 1 divided by 0. We can't divide by 0, so this is actually what we call undefined. Okay. And then moving around, these are going to look very similar. So the tangent of 180 degrees, again, 0 divided by negative 1 is 0. And at 270 degrees, the tangent will again be undefined because we can't divide by 0. Okay, and next year you guys will look at the graphs of those and make some sense of that graphically. So hopefully that makes sense as you're constructing this. If you just look at the unit circle, it just looks like chaos, looks like a little bit like a mess. But when we know where it comes from, then we can actually construct the pieces of it. We can memorize parts of it, and it can become very useful as we're solving trigonometric equations. So again, on your assignment, you'll be asked different questions, like I'm going to do just a couple of them down here. If I were to ask you what is the sine of 210 degrees, you would look at your circle, you would find 210 degrees, and you would find the sine value, which is the y value of the function, and you would say it's negative 1/2. That would be the answer. You will run into some on your assignment that say for what values of theta, it'll use that little thing, and it will say when theta is between, I meant for that to be a 0, is between 0 and 360 degrees. Let's say if the cosine of theta is equal to 0. And what you would do is this, I just don't want you to get confused by this part. All this means is I'm restricting the domain to once around the circle. So I'm saying you're only choosing rotational values once around the circle, so you're never going to go around it more times, okay? So this says what for what thetas or what degree measures is the cosine equal to 0. Remember, cosine is the x value, so you're going to look at all your points and you're going to figure out where is my x value equal to 0. Well, there it is, right? At 90 degrees, my cosine is 0. And if I keep looking at my points, my x values, it looks like it's again 90 or 0 at 270 degrees. So there would be two solutions on this one. We would say both 90 degrees and 270 degrees would create a cosine of 0. All right. Work through those practice problems, and then on the back page it gives you a unit circle to practice with. We're going to do kind of a practice quiz next week.